Welcome for joining us for this presentation concerning acoustic louvers. And today's presentation is entitled Acoustic Louvers, Performance and Structural Terminology and Application. It's actually a third in a series of Kinetics acoustic louver presentations. And the other two previous webinars were successful applications of acoustic louvers and then introducing our new airfoil blade acoustic louver. Those can be found on the Kinetics website if you haven't seen those yet. I like to get started. I always tell people when we start a presentation, you kind of have to get in the mood. So let's talk about some initial setup here. And, you know, what is an acoustic louver? I think a lot of us know an acoustic louver is not a weather louver necessarily. It's not a single blade louver. And it's non-operable. A lot of people ask if they can be used like dampers. They are fixed blade. They can be used in conjunction with dampers or weather louvers. But we like to refer to them as short stubby silencers, if you know what a ventilation silencer is, because very often they are used in most cases where you can't fit a silencer. There's just not enough room. There's space restrictions. You can't fit a silencer. So instead you might use an acoustic louver that might be 6 inches deep up to 2 foot or 24 inches deep. And if you continuing on, different applications, general building. I have some pictures here, general building ventilation, generator room intake and discharge vents. You can look at incorporating them into acoustic barrier wall system. A lot of applications, both because of the look, acoustic louvers look neat, and then also we might need a lot of airflow. So picture a barrier wall on a rooftop, and it's an equipment yard up on a rooftop of a building, and the architect likes the look of the louvers, and the mechanical engineer says, I need the ventilation because I'm so congested up here with equipment. So a lot of people, instead of our noise block solid panels, they'll actually make the whole barrier wall system out of acoustic louvers. We can look at acoustic enclosure ventilation, noise block enclosure ventilation, just fresh air in, for discharge air out, keep the temperature correct, no overheating. Air-cooled chillers and cooling towers, mechanical room, general mechanical room ventilation. But the other thing is too, is in some cases, and you can see in the lower right corner here, is single and double leaf ventilated doors. The whole door can be made out of an acoustic louver. The leaves can be entirely made of acoustic louvers, which is a really neat option. If you look at the mechanisms on acoustic louvers, before we get into the nuts and bolts of this presentation, is louvers the blades are angled, and we want to prevent or minimize any direct line of sight. We're trying to get a lot of noise control in a small depth, and so we want to prevent, and in some cases we can prevent the line of sight, and others minimize the line of sight. The top of each horizontal blade of these louvers is solid, and that gives you the blocking characteristics of noise from one side to the other. Then the underside of these horizontal blades are perforated metal, and that gives you absorption because behind that perforated metal, it's filled with an acoustic media. And typically, for those that want to take further notes, the acoustic media, the perforated metal is usually about a 23% open area. We look at relatively large absorptive surfaces. That's what we're trying to get because we don't have the depth. So we have to make sure that the underside of these is completely absorptive, and that compensates for its lack of depth. Some of the things that we vary when we look at different models we can make available to you of acoustic louvers is we can vary the angle of these blades. These are side views, so we can vary the blade angle from, maybe 30 degrees, 45 degrees, 60 degrees. We can vary the blade height or thickness, the vertical thickness or height of the blades, the depth of the blades. So that's the left to right depth here of the louver itself. And then we can vary the spacing, the percent open area between the blades, and the number of blades. You'll find out that we can have either same percent open area between two louvers, two acoustic louvers, same percent open area, but one may have fewer blades and the other one may, and they're thicker, or one may have thinner blades and there's more of them. And that kind of tunes the sound spectrum, whether it's low, mid, or mid to high frequency noise control. And then of course, all these changes we can make affect the pressure drop of the louver, which then is paired with the available external static in the system. We often get phone calls. People will call us who are used to using weather louvers, and right away they say, I need acoustic louvers because I need to control the noise through a passageway or opening, but it must be 50% open area. Now, I did a lot of research on this because we get this call a lot, and what I've found is that 50% open area is a great rule of thumb when you're sizing single blade weather louvers. Okay, that's kind of where it started, 50 to 60% open area, and it's a great place to start, but not the case for acoustic louvers. Acoustic louvers, the restriction is one of the things that help you tune how much noise control you're going to get. So when we get the call, it must be 50%. There's got to be a real good reason for that, and a lot of it is just the rule of thumb in sizing louvers for single blade is where that came from. If you look at the different models of louvers that Kinetics can offer, you'll see the different models here. Some are just like to the right all the way as our airfoil blade louver, looks like an airplane wing airfoil blade. You have a louver with just sloped air passages, and then the one on the far left, you have what's called a V-shaped air passage. That's a true no line of sight louver. It's also our maximum performing noise reduction louver. But you'll see here, each of these louvers range anywhere, for instance, anywhere between 30 to 50% open area. And as you can see, that's less than that 50% open area that people say they must have. And but we look at instead how much back pressure, how much pressure drop with air flowing through this is going to be result to then match your external static. And sometimes it requires, because you need a smaller percent open area, sometimes you need to enlarge, especially if it's a retrofit application or even a new construction. You may have a larger opening in the wall than you would for a weather louver, just because we're trying to balance the reduced percent open area, the back pressure, against the amount of noise control we can offer. So what's going to be covered in this presentation is we want to talk about transmission loss and noise reduction and what the difference is, and which one we should use when we're designing a system or specifying a system. The next thing is pressure drop, and then we'll also talk about water penetration. Now we're just going, even though we're diving deeper than our normal presentations, this still is a higher level discussion, and we can dig deeper. Just contact your local rep or the Kinetics office. So what to specify? Very often, should it be transmission loss or noise reduction? Which accurately represents the acoustic performance of the installed in situ louver. In other words, how is the louver going to be installed with respect to the whole building system? And a lot of times what you'll find is I see people specifying transmission loss when in fact they should be specifying noise reduction. And we'll get into that right now. So when we look at transmission loss is values, it's per test standard ASTM E90. And basically what we have here, you have the transmission loss between these two rooms. We have a source chamber here, a reverberant source chamber, and we also have a reverberant receiving room. Now this receiving and the louver test specimens in between the two rooms. Now this room here, the receiving room has, per test standard, has to have a certain level of diffusion. We call it good diffusion, but there are equations and tests that you do to make sure you have good diffusion in that room. And also it must be equal to or less than a certain maximum room size, so you truly have a reverberant space. So that's what's important in TL, is when you're measuring the noise between these two rooms where you have a reverberant receiving room. However, TL is not accurate when the receiver is either close to this wall or it's measuring noise across here where this room is very, very large or infinitely large. And so we'll talk about that. So this is transmission loss per test standard, noise between two rooms. However, when you look at this picture, a majority of your applications for acoustic louvers are set up this way. They're between the building and the outdoors. And it's an outdoor noise issue neighbors complaining, not meeting the noise ordinance, whatever the reason, but it's noise escaping from a confined source room, such as inside a mechanical room. And this one, there's generators behind here, and then the noise outdoors. So when you look at that, we talk about what's called a free field. We start getting into noise reduction, and we look at free field. So a reverberant to free field replicates typical acoustic louver installation external to a wall building. And so what you really have is this source, reflective source room. Then you have the outdoors. And then what they do is they take measurements just upstream or inside the source room to the louver, and then outside the source room to the louver. But remember, outdoors, there's no big reverberant field out here. And so what you find is you have a free field conditions that actually affect your noise levels. And you come up with what's called a noise reduction, which is actually a different value. So here it says for sound, noise reduction NR, for sound that is radiated from an enclosed reverberant space, such like a mechanical room, to the outdoors, there's no longer a reverberant field. The room constant in the equation, I was going to put all the equations in here. They were in here. I got rid of them. I said, John, that's going a little too in depth. But what you find out is that the room constant goes to infinity. And what the equations reduce to in their simplest form is noise reduction equals transmission loss plus 6 dB per octave band. So what does that really mean? So if we look at an example here, and you look at some transmission loss data as reported per ASTM E90 for an acoustic louver, that's what we have here in this column entitled TL. These are all in decibels per each of the 8 octave bands from 63 to 8,000 hertz. That's what the transmission loss is. However, I have this in the external wall of a building, and the other side of the louver is outdoors. And so now you add that 6 dB, and you can see for 63 hertz from 4 dB, you actually rise up to 10 dB reduction. And so these are the values in this column here under NR, what you can really expect as an acoustical consultant, as an engineer, as a designer, on what you're under this condition, what your real noise control would be due to that louver. And it's quite a bit more. Well, it's 6 dB more per octave band. Now you still have to take into account then these ASHRAE outlet conditions, 1, 2, 4, and 8, 8 being a very reflective, lots of buildings in an area, in an alcove or something like that. So that could be almost reverberant, but it's still not what you have here, such as the test standard E90. So you want to go with, under those conditions where you're exiting to the outdoors, you really want to use noise reduction in your analysis. If you look at all the different acoustic louvers that Kinetics offers, regardless of depth, regardless of any of that, if you just look at the maximum available that can be reported, the no through line of sight, the blue curve, is the one that outperforms them all. But it would make sense, right? You have a V, victory, as in victory, shaped air passage. And so there's no through line of sight. You don't have any beaming of noise in the angle of the opening or anything like that. So that's always going to give you the best performance. And that one there that's reported is also a 24-inch deep acoustic louver, okay? That means it's the max available in a KCAC no through line of sight model. The other ones are all up to 12-inch deep, and these are how they compare. You have your KCPL, which is a more architecturally looking, it has thinner and more blades. You have a KCFL, which is the airfoil blade louver, looks like an airplane wing. And then you have the tried and true KCAL version, which is one of the first versions we came out with many, many years ago in the late 40s. I'm sorry, the late 50s. Another thing that people call up a lot is concerning pressure drop. They'll often call and say, I need to figure out the pressure drop. I'm trying to size an opening in the wall for your acoustic louver. I need the percent open area. And the way Kinetics publishes and normalized our test data for pressure drop is, instead of using the percent or what we would call a passage area or passage velocity, we use face velocity. It's a lot easier for the end user to then go in the tables and find the pressure drop. And the face velocity is just simply the height and width, height times width of the size of the louver or the size of the opening of your building. So if you have an opening that's 12 foot by 12 foot and you got 100,000 CFM going through it, you can very easily calculate the face velocity and go into our data tables and find that. You don't need to call, you don't need to know the percent open area, you just need to know, and it's like any test data. You can test something one way, but you can report the data in other ways as long as you reference to the user what variables are being used in the pressure drop calculation. So this one would be 313 feet per minute. It only uses the face velocity. It's very easy then to determine your back pressure without looking in the tables here. That wasn't my point. My point is another one is some people will publish data based on passage or free area or a passage velocity. And, you know, it requires the engineer just that, to know the percent open area. So they either have to call, some manufacturers actually publish the percent open area on all their louvers, but some do not. And so in this one, you actually have to calculate the open area percentage, use that area and the airflow, and you find out, of course, the passage velocity would be greater, right? You're restricting the flow. You're only going through that open portion of the louver. So neither way is wrong. Just always know what's referencing. Kinetics uses face velocity, which is very easy. You know, the width and height of your opening. Some people publish it. Passage velocity, in that case, you need to know the percent open area. And it's really just an extra calculation step. When you look at the various models of louvers, you see they vary. You have the face velocity, because it's kinetics, face velocity on the horizontal axis. You have the pressure drop in inches water gauge on the vertical axis. And you can see for the different models, of course, the one for the no through line of sight, you're going to have the highest pressure drop, this top purple line. Then we have our KCPL, which is the KCFL, which is the airfoil blade louver, the KCPL, more architecturally looking, they kind of jump between the two, and then the KCAL, which is a much lower pressure drop. But the point here is there's different models, different noise reduction, different pressure drops, so you can then pair it against your back pressure. Do you have a 1/4 inch available? Do you have a 1/10 of an inch available of external static? Maybe you have 3/10 of an inch available, and you compare it, and there's a lot of models here to choose from for a given face velocity. Another thing we look at is water penetration. You know, years back, the only people that reported water penetration were weather louver people, people supplying weather louvers, because that was the point. But over time, it's kind of bled in, and people have wanted to look at the water penetration on acoustic louvers. Acoustic louvers are a little different, but water penetration can be controlled with some guidelines. And so what we've done here is, you know, when you look, now this isn't wind-driven rain, this is water penetration. So when you look at this, it's going to vary with percent open area. And then also the beginning point of water penetration, the cut point that you want to look at, is 0.01 ounces per square foot. And that per the standard. So this isn't pass fail, this is just how they perform. And so if you want to control that on the different no through line of sight louvers, we give you guidelines at Kinetics based on the airflow and the depth of louver, shall we say. You can either go up from 280 feet per minute face velocity to 618 feet per minute face velocity, and you'll be fine. And it all depends on the depth of that model. Same thing here for the KCPL. So we've given, these aren't passage velocities, they're face velocities. And we've given you guidance on each of these to meet this beginning point of water penetration. If you stay within these values for a given thickness, we can give you expanded data here based on thickness, so we can help you with that. But that gives you guidelines. Another thing that happens a lot is remember I mentioned people wanting to use acoustic louvers for barrier wall systems. They may have huge openings in walls. The walls might be 20, 30, or 40 feet wide and 20 feet tall. And so they're building, you have to support that, right? You don't just have to support the weight of the acoustic louver, but you have to support the moment forces due to wind and the locally adopted IBC wind speed and things like that. And you have to look at seismic and all these different things. So Kinetics is very involved with our own structural team in-house. We have our own structural team in-house since we do all kinds of seismic and vibration systems design and product manufacture. But it's nice to have them here because you're going to either just install louvers in a building opening. You may want the whole system designed and supplied by Kinetics, including the structural support steel, not just the louvers. Somebody may have designed a third-party structural system and it's all designed and they want to flush mount it to the front of there. Maybe the architect doesn't want to see the structural steel behind. And then we look at intermediate bank. So that's what we're going to cover right now. If you're looking at a building opening, the nice thing with acoustic louvers is the way Kinetics makes our acoustic louvers is the outer shell is a box. It's a beautiful box, usually 16 gauge galv or galvanneal or equivalent strength aluminum or stainless steel. And you can fasten to that outer shell. So putting in, this is an elevation or it could be a plan view, doesn't really matter. You have some substrate here that we show. And then you have an acoustic louver. You can either have it flush mounted, you can have part of the acoustic louver sticking out or into a building. And what you'll find is you can use anywhere from 1 by 1 by 3/16, most often 2 by 2 by 3/16, or sometimes if the gap is large or whatever you're doing to try to mate to a substrate, might be 4 by 4 by 1/4 inch steel. It all depends on what the structural design requires. And you can fasten those using, anytime you go from structural to sheet metal, you can fasten it using a tech screw number 5 drill point. That's great for sheet metal to structural connections. So that's a pretty simple, putting a perimeter frame around a louver to mount it to the inside of a building. Another method could be if you have, these are elevation views, let's say you have HSS tube steel beams and you want to mount, this exposes the structure. You would see the structure from outside once this is installed. But these are different methods that you can use to install louvers within a given structural system. Now, another way is if somebody wants to completely hide the structure. So this particular, I don't know if you can see it, the acoustical louvers are right here on the left, and just inside is a tube steel, both beams and vertical column support system. So there's a way that you can actually piggyback the louvers onto that system. And here you might see an angle at the bottom of that system taking in the vertical weight, maybe a 12 gauge formed U channel. Painted and to match the louvers themselves, and then a top channel that pulls it back, and all to avoid, both vertical weight issues here, but also moment forces due to wind. Especially a lot of these are up on a building. You don't want it to fall down and hurt someone. And then also you can put angles to, these can all be retrofitted or added to a structural system that's already made, and fasten that to the louvers. And that's a complete system. You would not see the louvers from the outside of this. Looks very nice. Now, some engineers, instead of using HSS steel, tube steel, they may use W columns and W beams. Very similar things can happen with this. And in this case, it's actually a 2-tier system, and you can actually put a formed H joiner in here. So you stack louver upon louver and have some supporting at the bottom. So there's a lot of things that Kinetics can help you with. We have details. The engineer and structural engineer can do as much as they want, or Kinetics and your local Kinetics rep can help you with it all. When you're banking a large set of louvers, this is kind of small here, but there's just 4 louvers, but when you're banking a set of louvers, one of the things that happen, we already looked at all the mounting methods, but everywhere there's a butt joint between 2, this is 1 louver module, 2, 3, 4, and they come shipped to the field as 4 pieces, 4 smaller louvers. You'd have them banked in the field, and wherever the butt joint is, we actually use joiner flashing. The picture down below shows that joiner flashing to cover that up. The only difference here is most of the time we powder coat or kind of wet paint our systems. And of course, I pulled a picture with no painting. But you can kind of see what we're doing there to cover up that butt joint and also help with securing those louvers together. One other thing is intermediate reinforcement. This particular bank, not really large, but it is almost 13 foot tall and it's about 18 foot wide. And we have smaller louvers that are banked and stacked up. And they're in this red perimeter, there's a perimeter angle that runs all the way around. Now, often we'll get the question, do I need any more structural support steel? And what we do at Kinetics is our structural team will look at this. They'll look at the IBC adopted wind speed. They'll look at the classification of the building. Is it on a roof? Is it on grade? They look at all that. And then often you will need to add external reinforcement. These are plan views here in the upper left. And then the bottom ones in the lower left is an elevation view. But you have to use either some W columns or some HSS columns to support that, because it won't support due to the wind forces hitting it perpendicularly. So at times you will need backer supports there. And that's one of the things you can ask Kinetics, depending on the model of louver, the gauge of the louver, the width of these individual banks, we can help you locate those as a service, no problem at all. And just wanted to show you a few pictures here. Is the one on the right actually shows that surface mounted louver, really cool. That's a no through line of sight 6-inch louver. You can see the engineer of record design the steel themselves, and then you can see the C channel at the bottom and the receiving of the louvers, and then a cap channel at the top pulling it back to the column. Same thing here. This is the equipment yard, cooling tower, and they replaced all the weather louvers with acoustic louvers. These were all then tied back to the steel. Over here is that's that same cooling tower equipment yard on the left called Bell Plant. On the right, this is actually a big generator enclosure of a number of generators, and this is used in conjunction with our noise block panels, but also skirted with acoustic louvers. And that's important to allow air in low. This was open top. And then you can get into some very large projects, a process equipment building, where you can see the different tiers and the nesting of louvers. These are all acoustic louvers. They're all 4 foot by 8 foot. No, yeah, you can't see there's a split in here, but they're 4 foot by 8 foot. So this is actually 16 feet between two horizontal beams. And so that's all mating into place as well. So really, it's not a long presentation, but it did take it a little further. Things about noise control and transmission loss, when to use, guidelines for water penetration, and then we talked about different methods of structural attachment and pressure drops. So I hope you enjoyed the presentation. I don't know if we have any questions. If we do, we have a few minutes to answer.
Okay, John, question for you. What is the maximum height of a louver?
So that is a great question. And what we do is we look at every project individually. Our standard height that we would like to make as one single louver, factoring in the weight of a louver to make it and move it around the shop, depending on its thickness, factoring in if it has to go through a powder coat line or batch painting, factoring all that in, we like to start with a 4 foot width by an 8 foot height. All right. However, we can do 4 foot by 10 foot or 5 foot by 10 foot. 5 foot's about the max width. 10 foot gets to be about the max height in order to fit it properly through powder coating, and most of these are powder coated. But what we do is when we get beyond that 4 foot width, then we start looking at using different thicknesses of blade, that solid top part of the blade. Instead of a 22 gauge, it might go to an 18 gauge. And so we start looking at things, but we have all the abilities at Kinetics. We try to hone in on 4 foot widths by 8 foot heights, but some people, the architect might want to look and line certain lines up, or it might be a retrofit and we're trying to hit some steel. If we have to go to 4 foot wide by 10 foot tall, we can. Some of it's limited by weight. When we convert to aluminum, that takes that weight factor out. So not a loaded question, but 4 foot by 8 foot was what we would prefer to start with.
All right, another question. Which acoustic infill provides best acoustic performance? The material, the thickness, the density? Is the acoustic insulation having any layer to avoid erosion with the air?
So So the acoustic media fill, when it comes to erosion, is separated from the airstream with a 23% open area perf. So you're not going to get any degradation. There's actually been studies done at passage velocities of over 10,000 feet per minute, and very few microns of any of the infill are collected. So we don't have any problem there. The acoustic media that we use is a constant acoustic media for acoustic louvers. We don't vary that within acoustic louver. We found that sweet spot, and that's what we use. It's also meant for outdoors, so you could almost say self-wicking. So it doesn't need to be bagged like with a Tedlar, Mylar, or poly. It can be, sometimes customers will want it wrapped in a fiberglass cloth, but not an issue with water, even if it's unwrapped. Hope that helps.
What is the material?
That's the secret and the magic. Sorry. Yeah, it can be readily purchased, and it can be, so it's not some exotic material, okay? The density is important. You don't want something too dense. Very often you want to go in a 4 pound per cubic foot or less, preferably less, but you'll find out very little difference between 4 pound down to about 1 pound per cubic foot. So, but of course, using the most economic, the most readily available, and the one that's the most durable for outdoors is what we use.
All right, I don't think we're getting any other questions, so.
Well, thanks for joining us, folks.